The best way to remember organic chemistry reactions is to practice, and concept maps are a great way to integrate what you have learned in various organic chemistry chapters together. This is because they link reactions from one organic compound to another. In this video, we'll be starting off with propene, and we'll look at how these alkene can be converted into various organic compounds. Here, we not only look at reactions from the alkene chapters, but also reactions from other organic chemistry chapters like the alkane, alcohol, halogenoalkane chapters, and more. Hello, I'm Emily, founder and creator of emilylearning.com, where you will find loads of videos, summaries, explanations, questions, and more to help you ace your A-level and O-level exams in physics, chemistry, and math. In this video, I will be going through this concept map. Okay, so in this concept map, right, we'll be starting off with propene, which is an alkene, and we will convert it to other organic compounds and using different reagents under different conditions. All right. So we know in the alkene chapter that alkenes can undergo a number of reactions. The key reactions would be your addition reaction. Okay, you also learned about oxidation. So we'll be covering these in detail. All right, so let's first start off with those that involve addition reaction. So let's start off with propene. So what happens when hydrogen in the presence of nickel catalyst is added? Well, your propene will be converted to propane. All right, so we'll be adding H across the double bond. Okay, so this was what we started off with. Okay, so this is propene. So if I were to add hydrogen to propene, the CC double bond will break. Okay, and each of the carbon that initially have the double bond will have a CH bond form. Okay, so this compound here is basically CH3, CH2, CH3, and it is called propane. Okay, so this will be the product form when propene undergoes addition reaction with hydrogen. Now, propane is an alkane. So for alkanes, they also undergo halogenation, but they would require UV light, okay, or heat. So in the presence of UV light or heat, propane can undergo free radical substitution with bromine, and you will form bromopropane. Okay, so a variety of products will be formed. So this is one possible product form. So you have one bromopropane. You can also form two bromopropane. Okay, and if there are excess of bromine, you can have multi-substitution. So you can have di-substitution, tri-substitution, and so on. Okay, so there are a variety of products formed whenever you do a free radical substitution. All right, next, let's look at this here. So the reaction of your propene with hydrogen bromide. So remember, wherever we have an alkene undergoes an addition reaction with a polar molecule, then we need to apply Markovnikov's rule. So basically, the more electrodeficient group will go to the carbon with more hydrogen. Okay, or you also learn that H will go to the carbon with more H. So if you look at these two carbons here, okay, these two carbons are those that have the CC double bond, right? So this two carbon has the CC double bond. So your H and your Br will go to these two carbons. So which carbon will get the H and which carbon will get the Br? Well, the carbon with more H will get H. and the carbon with less H will get Br. It is like the rich get richer, the poor get poorer, right? So if you take a look at this carbon here has 2 hydrogens, right? This carbon here is only directly attached to 1 hydrogen. So in other words, right, this H will go to the C with more H, which is this. And the Br will go to the carbon with less H, which is here. So the major product formed will be this. All right. Next, let's go on to the next reaction where propene reacts with bromine in CCl4. So Br2 in CCl4, okay, we will basically have the each Br going to each of the carbon here, right? Okay, so this will be the product. Okay, so we have looked at propene, okay, undergoing electrophilic addition with bromine in an inert solvent like tetrachloromethane or CCl4. Next, let's look at what happens if propene undergoes reaction with aqueous bromine. So now, recall in your electrophilic addition mechanism, in the first step or in the slow step, right, you will need an electrophile, okay, to attack the C double bond. Okay, so water will not be involved in the first step because it does not provide the electrophile. For your bromine or your halogens, when they approach the electron-rich CC double bond, this molecule get polarized. So the Br that is closer to the CC double bond will get a delta plus sign, okay? While the Br that is further away will get a delta minus sign. And this Br delta plus, okay, acts as an electrophile, okay, and reacts with your propene or your alkene in the slow step of this electrophilic addition reaction. Okay, and you will form this carbocation. Okay, so remember the positive sign or the cation, okay, or the plus sign will be given to the carbon that is attached to more alkyl group. Okay, so if you have to consider this carbon here, it is directly attached to 1 alkyl group and 2 alkyl group. Or maybe if you look at this carbon here is attached to 1, 2 alkyl groups. Whereas for this carbon here is only attached to 1 alkyl group. All right. So in other words, this carbon will form a more stable carbocation, okay, because there are 2 electron donating alkyl group that will lessen or that will reduce the intensity of the positive charge on the carbon here. All right, now, once we have formed this carbocation, next we'll move on to the fast step. So in this fast step, because we have a carbocation, anything that is negative will react with it. So what negative species do we have? Well, we have Br minus that is being formed because this Br bond breaks and these 2 electrons goes to this Br, right? So you have a Br minus here. In addition, because we have Br2 aqueous, we also have water. Okay, and we know that the concentration of water will be much higher in an aqueous solution compared to the concentration of Br minus, right? So the probability of your carbocation reacting with water is higher than that reacting with Br minus. So therefore, this compound here will be formed in greater amount compared to this one here. All right, so for this product here, it is formed when the carbocation ion reacts with water. For this product, it is formed when the carbocation ion reacts with Br minus, because the concentration of water is higher compared to the concentration of Br minus. Therefore, you will form this product in greater amount. So if so in the exam, if you're asked to draw the major product, then this would be your answer. All right. Okay, next, let's look at propene undergoing a reaction with concentrated H2SO4 coal followed by H2O heat. So basically, this is a hydration reaction. So at the end of the day, we are going to add H2O to propene. So H will go to one of the carbon and OH will go to the other carbon. So this follows Markovnikov's rule. So the H will go to the carbon with more hydrogen, which is this one here. Okay, and the OH will go to the carbon with less hydrogen, which is this carbon here. So the product you'll get will be this. Okay, and this product here is basically an alcohol. And if you take a closer look at this, this is a secondary alcohol, right? Because this C has one H, or this C that is directly attached to the OH group is directly attached to two alkyl groups. So this is a secondary alcohol. If a secondary alcohol were to undergo oxidation, then it will form a ketone. So basically, the H and the OH will change to a double bond O. Okay, so this is the product form. This is propanol. Propanol. All right. Now, what happens if the alcohol reacts with alkaline iodine and is heated? Well, when we see alkaline iodine, it is basically your iodoform test. So during an iodoform test, what happens is one of your CH3 will form CHI3. Okay, and is replaced by an O minus. Okay, so this would be the other product form. So one of the CH3 will form CHI3. Okay, and you change this portion to O minus. Then the H and OH forms a double bond O. Okay, and the rest remains. So this will be your product form, your organic product form, when 2-propanol, which is an alcohol, undergoes iodoform test. All right. Next, let's look at this reaction. So basically, these two reactions here are oxidation reactions. So for your oxidation reactions, right, you have the mild oxidation, which involves reacting your alkenes with co-alkaline KMNO4, and basically what you get is a diol. Okay, then you have your strong oxidation. So you have an oxidative cleavage. Your CC double bond will break. Okay, so let's start off with this. First, you have a co-alkaline KMNO4. So whenever you see a co and KMNO4, okay, what happens is this is a mild oxidation. You'll form a diol. Okay, so the CC double bond breaks. Okay, and you will replace the bond that is broken with OH. So you form this diol here. Okay, next, let's take a look at this. So for this, we have propene reacting with hot acidified KMNO4. So this is oxidative cleavage, right? So during oxidative cleavage, the CC double bond breaks, okay? And if you have a CH2 group, okay, then you will get CO2 and H2O. Okay, then this portion that is not a CH2 group, what happens is the carbon will have a C double bond O. The H will become an OH. Sorry, this CH. Okay, then just copy what you have here. So you have ethanoic acid being formed together with liberation of carbon dioxide. All right. So if the question asks for organic product, then you just need to write ethanoic acid as your final answer. You can follow this video by downloading the PDF that I have created on Organic Chemistry Concept Maps Part 1. Okay, so I'll provide a link in the description below where you can download this concept map. So at the end of the blog post, okay, you will see this here. So simply just put in 0, okay. No credit card information is needed, and just type in your email and you will be able to get the PDF copy of the concept maps that we are going through together with the answer key.